If you're a regular viewer of my channel, you'll know that the satellite series from Grundig is one of my favorite series of radios to date. This one came in with a problem. This was sent to me by a viewer as a gift, and I really appreciate it. He knows I haven't got one, and although this is not the Grundig, it's basically the same model. And this one came with a problem which apparently is quite common for these radios. The problem is that people blow them up by putting a power plug on the side or plugging in 6 volts from a normal wall wart. Now, why is that a problem? Well, the problem is that particular plug is wired with the center negative instead of the center positive. The problem really is that when you plug in the wrong supply, you've got reverse polarity on this thing, and this thing just was not made to work that way. Now, why am I doing this video? I'm not going to do a full restoration video. There's no point. This is really a quick explanation of how I repaired this and why these things go wrong and how to repair them, because apparently this is quite common and there's very, very little information on the web about this particular model and this particular problem, except the complaints that it's happened. Now, when I received this thing, nothing worked, and it was actually sort of pulled apart. You know, this little board that goes on the back was loose. This thing was on here, but this side was broken off. These two had been ripped off. Must have suffered a fall. And the back, well, the back was really open. This was in place, but this was exactly like this. This was exactly like this. This was floating in the breeze. The back was actually fitted in place, but someone had actually tried to repair this, didn't succeed, and just gave up. So I decided to try and find information on this, and that's where the problem started. I found a few complaints about the problem. I found a heck of a lot of forum entries asking for a schematic or service manual. I also found a lot of responses saying there was nothing like that available. What I did find was one particular gentleman who actually did a repair of one of these, and it wasn't found immediately on the web. I really had to search for it, but he actually explained what went wrong, and I've found that mine has exactly the same problem. The reason I'm doing this is to help anybody with the same problem to do this to their radios, because if I can contribute a bit to the information on the web, then obviously I'll be helping somebody else the way somebody else helped me. So that's what this is. It's going to be fairly short. Hopefully at the end of this, I'll show you the radio working, because at the moment, it's got a few patches here that sort of make it work, but not quite. But let me go into detail. The first thing I noticed when I opened this up was this board had a couple of these floating around. One of them was actually lying on the board. The other one rolled off the bottom of the chassis. And I didn't at first recognize what this was, but what this is an electrolytic capacitor that's been blown up. This is the casing of the capacitor. It's one of those. And a couple of these were soldered in certain points on the board. In fact, 2 of them. The first one was up here. It took a while to find it because there was paper and fluff all over the place. If you've seen an electrolytic blow up, you'll know what I'm talking about. So I went looking underneath, and underneath here, I found this particular symbol here. That's a MOSFET. And this particular MOSFET, I followed the power lines. It switches the power, the 6 volts coming in from either the wall wart or the batteries. It switches the power through, and this one has a hole in it. So that was quite easy to figure out. That had been blown. So being a MOSFET, this is a P-channel MOSFET. I was able to find the reference on there. It's a 2SJ245, I think it is. It's a P-channel MOSFET. Not that much power, doesn't have to pass too much current, but this is the supply to the audio section. And so what I did was I just shorted that up. I put a little wire between the drain and the source. And that's basically making the switch that the signal to the MOSFET would make anyway, okay? The signal would come from a microcontroller, which is powered probably all the time, if I'm not mistaken, and that would send a signal saying, switch on the audio, boom, and that would be made. So by doing that short, I'm leaving the audio section on all the time. Okay, that was not enough, because when I switched it on again, nothing happened. Nothing happened, so I went one step further. I looked at the other capacitor that was blown up over here, over there, and on the underside, I found a very small little bugger like this. And this one, I think, has got a hole in it as well. You can actually see a hole there. I had to use a microscope. But this one was a little trickier because I had to try and find what it is that it did. It's a 4-volt voltage regulator, low dropout voltage regulator from 6 volts to 4 volts, and it's supposed to be switchable, which means that if you have the signal sent by the microcontroller saying the radio is supposed to be on, it will switch on that little voltage regulator, and it will allow it to convert the 6 or 6.5 or 7 volts input to 4 volts and send that to the radio. But if that signal is an off signal coming in, it will just switch this off. So again, this is a switch on, switch off function, which is a bit similar to what this MOSFET was doing. It's being switched on and switched off by the microcontroller. And of course, getting one of those was a bit of a challenge, but I did find some, and I'm going to be trying this. What I did in the meantime is I used an LM317 with the right resistors to give me 4 volts. And this works. This actually works if you do it like this, with the exception of that off function. You can't switch it off because obviously if there's 6 volts at the input, it's going to give me 4 volts at the output. Actually, it's supposed to be 6.5. I think the dropout voltage is about 2.5. So again, that's another problem. If you want to use this with batteries and you've got 6 volts only coming in, it might not give you the regulated 4 volts. So that is a problem. But to try it out, just to see if it works, it was good enough. And I thought, okay, great. I found the 2 problems. So I switched it on and nothing. Which took me back to the gentleman's forum, or rather the write-up that he did on his. And he tells us there's another one of those things inside the inner board here. So I took all this out, and lo and behold, on the bottom, you'll find another one of those little 4-volt voltage regulators. And I did the same thing as this. And this is what happened when I powered it. When I give it power, it actually turns on, but the audio is always really on. It doesn't switch off. So if I put this on here, this is on FM. You get the idea? What's more, it works on all the bands. It works on FM, medium wave, long wave, short wave, the air band. You see that? It's supposed to be off, but the audio's just come on because that MOSFET is on all the time, as is the other voltage regulator. So whether it's on or not, there's still the hiss. I'm going to switch that off. The other thing I noticed is that when I switch it on, like that, it's just the digital section on. But when I look at the power supply, it's still drawing 100 milliamps. Now it's drawing 120 milliamps. So there's obviously a part of the radio that's drawing current all the time, and that makes sense. That MOSFET is on all the time. The 4 volts going to, I think that 4 volts there's going to the radio section, that's on all the time. That's producing 4 volts all the time. And so is the other 4 volts internally, which is not being switched off. Now let me tell you about these switch on, switch off voltage regulators, because they're very interesting. Right, let's start with this. This is the 2SJ245. That's that MOSFET. It's a P-channel MOSFET, and basically 4-volt gate drive from a 5-volt source, switchable regulator. This is the use case. So this basically is just a low voltage, not very much power. What is that? How much current? Yeah, it's a lot of current. 5 amps. That's a lot of current, but obviously this thing doesn't use anywhere near that much. So it's basically a switch, a high side switch to provide the 6 volts to the audio section. And again, I'll tell you why I know that, because I did find something. So this one, I tried to find a P-channel MOSFET, and you'd be surprised how few of those you'll find in your parts bin. For some strange reason, I've got a heck of a lot of N channels, but couldn't find one of these in this package. But I managed to find a replacement, and it was the IRFR 9024. Again, same pin layout, and this one is, again, 60 volts and 8.8 amps. A little bit more beefy, but the same form factor. So that solves our MOSFET issue. And then when I looked at the little 4-volt voltage regulator, it's got 4 VCW on it. And for the life of me, I couldn't find any kind of data sheets on that, but I did find some information on it on a Russian website, and this is sort of posts from a forum And they sort of draw this. Just my luck, I had to reverse engineer it before I found this, which would have explained a lot, although I don't understand the text here, but it would have explained a lot. But it does show you what happens. The 6-volt battery comes in here. It goes to this MOSFET. This MOSFET needs a signal over here, and if it gets that signal, it switches the power to the audio section. I think that's pretty self-explanatory. So this is a switch to the audio section. Forget about the red, because they go around trying to replace that guy. I've actually found something that I think will work. We'll see. Then how does this get switched on? Well, there's a little transistor here. That transistor gets a signal from the power signal on the MCU. So this microcontroller says, the power switched on, hit it. And it hits it with a high voltage here. This thing comes down to ground. That thing drops the voltage difference between the gate and the source drops, and of course that switches on. That's fine. Now what happens here? This is another strange one. This is the strange one, because it takes the same power signal from here to a 4th pin or input, 1, 2, 3, 4, on this 4 volts voltage regulator. So it's actually switching on the regulator. And that would provide 4 volts over here to the rest of the radio. That is on that outer board, on this that power board that I've showed you. What happens inside on the inner board is exactly the same, but I didn't find any information on that. I did find the component, and the capacitor next to it was indeed blown. So this was very helpful, but again, I couldn't really read this. I just happened to find this after a lot of searching. What they've done here is they've replaced this with a normal 4-volt voltage regulator, which is not switchable. I think the one I found will work. I'm not sure, but we'll find out today. Now, what did I find to replace this guy? Well, here it is. Now, what it is, it's a voltage regulator with an on-off circuit, ensures long battery life. Output voltage between 2 and 6, so there are various numbers, various references you can buy. 170 millivolts output dropout voltage, which is pretty good. I mean, usually it's about 2.5 volts. Very low current consumption when not operational. Output current possible 200 milliamps. That's more than enough. This whole thing doesn't draw that much. So I figured this would do. And the one I got is the 4-volt version. And they show us a block diagram on how this works here. You've got the voltage reference inside, the error amplifier, and it switches on a MOSFET as well. But it does have the on-off circuit, which is over here. Now, I'm not sure that this is going to be an absolutely exact fit, but we're going to find out. But here you've got all the voltages you can get, and the one that I got is this one. So that's the 4-volt version. And it's in, I believe, this package, which I believe is the same pinout as the one that was there. I bought a couple extra just in case I blow one or two. We'll see. So that's what I've got, and that's what I'm going to try and replace in here and see if the whole thing works. Work it does. I'm just trying to get the power management or power control working. I'm going to do this in stages. What I'm going to do is I'm going to put that MOSFET in here first, and that'll control the power amp section. I'll check that that works, see if it makes any difference to the current draw when this thing is supposed to be off, and see whether that audio comes back on after I switch it off. It shouldn't, because that should work. If that works, then I know the microcontroller is sending the right signals to it. And if that works, then I'm going to try and replace that little component there with the ones I bought and see if we can get this thing switching properly. So let me get cracking. That's in place. So I'm going to try it, see if the whole thing, if the audio is completely switched off when I tell it to. Okay, let's see how it behaves. I'm going to hit the power. Well, that comes on with no noise. Brilliant. Right, there's absolutely no sound from the speaker, so it tells me the MOSFET's doing its job, and it's switching off or rather it's not switching on the power amp section because the radio's supposed to be off. Now it switches it on. Okay, now let me try that other little guy. That's even smaller, so it should be fun. Okay, here goes. I've fitted that little voltage regulator. One of the pins there, the actual VN pin, was burnt. It had burnt a hole in the actual board, so that was scraped. So what I've done is I've used the lead from the capacitor that had blown up here. I've used that lead to make contact with the VN pin. All the others are connected. It fit nicely. I've put the capacitor in there as well. So we've got this completed. Now what I'm going to do is test it and see if that current draw drops when I switch the radio off. Let's check. Powering on the supply. It's promising. It's drawing 40 milliamps. Now it's drawing 110 milliamps. Now it's back to drawing 30 milliamps. Okay, so that little voltage regulator seems to be working, and it's cutting the power draw when the radio is supposed to be off. So let me just check something. That's FM. Long wave, medium wave, and short wave making the right noises. So let me go in and do the one on the inner board, and it'll also give me an opportunity to show you where to find it. Okay, we're on our way. I'm trying to remember how I took this out. I know there's some screws here. In the meantime, I'm just going to remove this. It's actually quite convenient. It comes out quite easily. And then, if I'm not mistaken, I just have to remove 1, 2, 3, 4, 5, 6 screws, and we should be on our way. I told you I couldn't remember. It was the wrong screws. The ones I had to take out were 1, 2, down at the bottom, there, and there. And I believe this whole thing comes out, but we've got a problem trying to get it through there. And this has got to come out as well. Well, would you look at that? So if you bend the antenna, it seems to do the trick. And I believe that hack that I did is, yep, there it is, on here. I'd forgotten where it was. But I'll get cracking on it, just get it done. And then I'll put all this back again. All right, time to get this thing sorted. I've also got to check that little battery there, or is it a supercapacitor? That's the one that's going to keep the memory. All right, time to get cracking. I fitted this the same way I did the other one. This is an LM317. I'm going to see what I can do. I don't remember how I removed that chip. I've got to remove this because the chip's on the underside, so I need to, there's how many screws here? 1, 2, 3, 4, 5, 6, and lift this up. Well, I'd forgotten about this. The rabbit hole gets deeper because once you've got this out, you've got a shield on the back. So I believe there's one tag soldered there. The others are just, and there's one over there. One over here. The other tags were not soldered. They just go through, and I've unbent them all. So it should be fairly easy to remove. Let me try that. Okay, it's official. I need a production team. I need a full video and audio production team, because when I started doing the inside of this, I thought I had the video going, and it seems to have not been on. It was on pause. But let me tell you what I did. I fitted that little chip in here. Now, you've got to be careful when you do that. You've got to make sure you've got the ins and outs. In other words, the voltage in, voltage out, control pin, well identified, because this thing was actually a different footprint. This is really weird. The one that I found in here was a different footprint to that one there. And I remember seeing on that one that there were actually 2 footprints. So there seems to have been 2 options of this chip. It was bad enough getting 1, getting 2 is impossible. So I had to be very careful to check which was the voltage in. And there's actually there's a legend on this band, this connector here. And the one that's important is VCC. Now that's the one that you have to make sure goes to the in pin, okay? What they've got here on this one is they've got the on-off pin connected to VIN, to VCC. So in other words, that's always high, so that particular voltage regulator is always on. That's the one that obviously controls the microprocessor, which is why this thing's always monitoring something and keeping the clock going and so on. So I finally got that done. I put the shield back, soldered everything in, put it in here, and then found out that I had no video. Anyway, the point is that's been done. That has been put in. 2 screws on here hold it in place. That connector's in place. That speaker wire goes underneath there and it clips into a little shelf on that end there. So it's all neat. And what we're left with now is the radio with the power connectors here. This is that audio that goes to the external input at the back, and this is the antenna. And that's really all we need to worry about. And those things are here. So we've got this little board that has the socket in there, center negative. And this fits in here. I've got to solder that wire to these two that were cut. This is how I got it. I'll make sure before I power it up that this is actually center negative and that I'm getting the positive on the red. Make sure that they haven't changed something here. You never know. And then, of course, the antenna's got a solder tag at the bottom that I solder that to. And really, that's it. Oh, and of course, that's been put in. And all that does is receives this guy. This just clips in there like that. And you've got the possibility of line in, or line out rather. So you can send this to an amplifier. Okay, what I want to do now is test this. Make sure it's working. I'm just going to connect the power supply again to there without much preamble and connect this to the bench supply and see what we get. It's just something I want to show you here. The connectors, the antenna connectors. There's a switch here that you can select between external and internal. The externals, you've got an FM1 with these BNCs and the shortwave antenna, also BNC. And then there is a shortwave antenna, long wire, if you want to put a wire on here, ground and long wire. I use the mini whip and I can connect it straight to that. Or alternatively, I can connect it to this guy over here. The AM is a little bit different. This antenna here won't do anything for the AM. Let me show you what they've got for AM. For AM, you got this really cool directional antenna, and you can actually check the degrees on there. 0 degrees to the front, so this would be very useful for direction finding. And I think these guys actually had a method of picking up beacons and using direction finding to position yourself in the ocean or wherever. But there's also a possibility of an external antenna here, which is here. There's a jack plug, a jack socket on there, a little 3.5 millimeter jack, and that's your external long wave, medium wave antenna input. So that is very useful. Again, that's something that I'll connect my mini whip to, because with the mini whip, I pick up everything over here. Let's test this out, see what we get. Put the power on the power supply. It's drawing 20 milliamps now. I can see the dials come on. Switch it on. It's come on to FM. I've just put in the FM antenna direct, and we can select, it says here, let's give it light. It says here internal antenna. If I select external, it's got the external antenna over here. Brilliant. There's another one on 99. I can enter it like that. There's another one on 101 point. I think it's 101.6. Yeah. Okay, so that's working very well. Let me change this to the shortwave. Shortwave. Let's go to let's see if there's anything on here. Go to the 20 meter band. It'll be upper. There's the SSB. You can have shortwave. Upper sideband, lower sideband. So at 14 we'll go to upper sideband. See if there's anybody on here. Doesn't seem to be anything. Let's try the 40 meters on lower sideband. Looks like nobody's on here. The usual. Let me go into AM. It's always much busier. Now I've got a little jack over here. I'm going to connect the antenna to that. Connect the socket. Connect the plug to the back here. Now if I take that off, if I take that external antenna off, I get practically nothing. With the mini whip, it's magic. This is the local station. Let's try long wave. There's BBC Radio 4 and 198. I can make it broad. It's not very good tonight. Usually a lot better than this. The point is, this thing is working. And it's working after replacing those three components that were blown out by that mistake, that error on the wall what they had on here. So that's the purpose of this video, just to show you how to repair that sort of problem, which seems to be more common than I thought. I had no idea so many of these had these blowouts. I also had no idea that these guys used that particular configuration, but I know why they do it. The reason they do it is so that you can connect battery, and those sockets, 2.1 millimeter DC power sockets, have the possibility of, when you plug it in, the negative, or rather the shield contact can get switched over. So what they do is they have the battery connected to that, and then when you connect the external, it breaks the connection to the battery and allows you to use the external supply. That is generally why a lot of these guitar pedals, use that system. I think it was Boss and also another one of the pedal makers started using that a long time ago. It became a sort of convention, but it is something you have to look out for. The one way to overcome that, and I'll probably do that, is to put a diode in series so you don't ever mess it up. In that case, you lose a bit of voltage, but if you use the Schottky diode, you're probably good. So yeah, that's the result of messing with this. And as I mentioned at the start, this was not supposed to be a restoration. It is by no means a restoration. I'm going to clean this up. There's not much to do here. I have no service manual, so in terms of alignment, I don't know what to do here. It seems to not need that. I've been playing with this the last couple of nights with that provisional repair that I had on here, and this thing picks up extremely well. And it's very easy to use. I like it. I actually like it. Now that's coming from me who prefers the old version stuff. This is probably sacrilegious, but I do like this radio. I'll probably still want to get the Grundig one, but that's just a little bit of excess on my part. So for now, that's about it. I certainly hope this video helps anybody who's come across the same problem. And I hope this makes their search a lot easier than mine was. So once again, I want to thank the viewer who offered this radio to me. Thank you very much. You wanted to know whether it was going to work. Here it is. It's working. So once again, just to let you know, if you want to support the channel directly, you can do so on Patreon and PayPal, links on the description below. Thanks for watching. Bye for now and stay safe.